Good morning, my dear students. In today's class, I am going to start Unit 2. Unit 2 is completely about the CW radar and FM CW radar. CW radar and FM CW radar. And first we will see the syllabus. First we are going to study Doppler effect. It is already known from the basics of the physics, and next we will study the basic operation of the CW radar and how to provide an isolation between transmitter and receiver and non-zero IF receiver, and what are the bandwidth requirements of the receiver and applications of the CW radar. All will be measured in the first part, that is completely about the CW radar. And the second part is FM CW radar. In the FM CW radar, we can measure both range and velocity, and that is the first concept, range and Doppler measurement. And next one is block diagram and characteristics of the approaching receding targets. And the next concept is FM CW altimeter. It is used in the aircrafts to measure height between the surface of the earth and the aircraft. And this FM CW radar, normal CW radar cannot measure the range, but by using a multiple frequency radar, CW radar, we can measure the range. That is the concept of multiple frequency CW radar. And our second unit is a continuous wave radar. The name itself indicating, in this the radar transmits a continuous wave. By observing the waveform, we can say that this is a continuous waveform having a frequency of f0. And this CW radar is used to measure relative velocity of the target. And here we have to understand one basic important concept, that is Doppler effect. The Doppler effect is when source of oscillation or observer of the oscillation is in motion, there is a change in the frequency. This is known as a Doppler effect. When source of oscillation or observer of oscillation is in motion, there is a change in frequency. This is known as a Doppler effect. The Doppler effect can be understood with the help of this diagram. Suppose the vehicle is moving and it also giving us some sound, some horn also. It is a source of oscillation. The vehicle is a source of oscillation because it is giving the horn, and some person is standing here. The person is a observer of the oscillation. When vehicle is moving towards this person, the frequency will be increased, f0 plus fd. Suppose the vehicle is moving away from the person, that the frequency will be decreased, f0 minus fd. That means when the source of oscillation or observer of the oscillation is in motion, moving condition, there is a change in frequency. There is an increase in frequency or decrease in frequency. This is called a Doppler effect. Already we know from the radar equation, the total distance traveled by the electromagnetic signal is 2r. The total distance traveled by the electromagnetic signal is 2r. Therefore, the total number of wavelengths present in that distance is 2r by lambda. The total number of wavelengths in that distance is 2r by lambda. And what is wavelength? Wavelength corresponds to the angle of 2 pi radians. The one wavelength corresponds to the angle of 2 pi radians. Therefore, total angle is given by 2 pi into 2r by lambda, that is 4 pi r by lambda. The Doppler angular frequency is given by omega d, that is equal to 2 pi fd. Already we know that omega d equal to d phi by dt. We know that angle phi equal to 4 pi r by lambda. 4 pi r by lambda. By substituting this, we get 4 pi by lambda into dr by dt. The dr by dt, distance by time, it is nothing but a velocity vr. Therefore, omega d equal to 4 pi vr by lambda, where fd is Doppler frequency shift and vr is the relative velocity of the target. And then by cancelling 2 pi and 2 pi, we can get fd equal to 2er by lambda. It is called a Doppler frequency shift. And next we will discuss about CW radar operation. What is the block diagram of CW radar and how it works. All these things will be studied in this concept. We will see the radar block diagram. The radar block diagram consisting of a CW transmitter. It generates a continuous wave with a frequency of f0. It generates a continuous wave with a frequency of f0, and this signal is radiated with the help of the antenna. By using this antenna, the waveform is radiated. And whenever this signal, the transmitted signal, whenever it hits the target, some of the energy is reflected back. That is called a reflected echo. This is echo signal. The echo signal is captured with the help of the receiving antenna. This the second waveform is the echo signal. The echo signal is captured with the help of receiving antenna. The received signal, the received echo signal amplitude is low. By observing the waveform also, it is a low amplitude signal because it is traveled from the very long distances, so that the amplitude of the echo signal is reduced. Suppose if the target is in motion, according to Doppler effect, when the target is in motion, there is a change in the frequency. Suppose target is approaching. We know that if the target is approaching, the echo signal frequency is f0 plus fd, and if the target is receding, the echo signal frequency is f0 minus fd. If the target is approaching, the echo signal frequency is f0 plus fd. If the target is receding or moving away, the echo signal frequency is f0 minus fd. Therefore, the echo signal frequency is f0 plus or minus fd. And by observing this CW radar block diagram, the transmitted signal is f0 and the received the echo signal frequency is f0 plus or minus fd. And the next block is the mixer. The mixer having two inputs, one signal having frequency of f0 and other signal having a frequency of f0 plus or minus fd, and the mixer will generate a beat frequency fd. The fd is called a beat frequency or Doppler frequency shift. And the next block is beat frequency amplifier. This beat frequency amplifier, it is also called as a Doppler amplifier. It is also called a Doppler amplifier, and it eliminates the echoes from stationary targets. The stationary targets are not required because like buildings, trees, all are stationary. The echoes from the stationary targets is not required. This beat frequency amplifier will eliminate the echoes from the stationary targets and also amplify the echo signal. And this the received signal after processing it is given to the indicator. The indicator may be a earphones or frequency meter. That means we are getting the in this CW radar we are getting Doppler frequency shift FD. Doppler frequency shift FD. It is used to measure the relative velocity of the target. This is about the CW radar block diagram, and thank you very much.